what we have here is what's called the lens maker's equation. If we make a lens with a radius of curvature R1 on one side and a radius of curvature R2 on the other, and often when we make lenses these two are equal, but they don't have to be, and I've depicted them to be different here. If R1 is the radius here, radius of curvature, and R2 is the radius of curvature here, then the focal length is given by this equation, where n is the index of refraction of the material. And since we usually use lenses in air, which has an index of refraction that's very close to 1, this is going to be our equation. Okay, if we were in something other than air, I think this would be n2 minus n1. But let's not worry about that for the moment. Okay, now we can apply this to the lenses that we've observed. Okay, the water lenses that we made by taking pieces of glass spheres, broken pieces of glass spheres, and mounting them on horizontal surfaces, the radius of curvature of the glass part, the spherical part, is just r, whatever the radius of the sphere happens to be. The radius of curvature for the straight line is infinite. That is, the further away the center of the circle gets, the flatter it gets. When the center is at infinity, it's perfectly flat. So we have R2 equals infinity here. Now, we have R1 equals R, R2 equals infinity. If we look back up at the lens maker's equation, if R2 is infinity, then this term is 0, and we just have n minus 1 times 1 over R, or n minus 1 over R1, which we just designate as n minus 1 over R. We represent it as n minus 1 over R. So 1 over F is n minus 1 over R. Now, for a 10 centimeter radius water lens, 1 over F should be then n minus 1 is about 0.33 divided by 10, okay, centimeters. If we solve for F, it's going to be the reciprocal of this, 10 centimeters over 0.33, which is about 30 centimeters. Now, the actual lenses that we observed had radii of 4 inches and 3 inches. Now, 4-inch radius, not radii, but diameters. 4-inch diameter corresponds to 2-inch radius, which would be a 5 centimeter radius, which would give us a focal length of about 15 centimeters. We'll note that that's just what Josh observed when he measured the focal length of that lens. And he observed around 12 centimeters for the other that had a diameter of 3 inches.